All right, welcome. I'm excited to see y'all here. Quick question, who's been to one of my talks before here at BrickOn? I don't know why you guys always come back, but thank you, that's awesome. So we're talking about programming and coding. Who's done any kind of programming or coding in LEGO? Okay, you guys can go, because you don't need this, you already know this. Who's done programming and coding but not in LEGO? Okay, there we go, excellent. And calling up your app and asking Siri to do something does not count as programming and coding in LEGO. All right, so let's get through this. I got a lot to go. I'm going to go probably 40 minutes or so, and then squeeze in some questions at the end. If we run out of time, we got to vacate the building, or not the building, the room, and I'll take questions and stuff in the hallway afterwards if need be, if that's okay. This is what I'm hoping to get through today, all these fun things, and let's get right into it then. The systems. What systems am I talking about today? Hopefully you've already kind of figured this out, but LEGO does have lots of programmable systems and have had many systems throughout the years. I'm not going to get into the whole history of them, but I'm today going to be talking about the Mindstorms EV3, the Powered Up, and the Spike Prime, because those are relevant and current, except for the Mindstorms, that's kind of discontinued. But I still find it relevant because it's awesome, in my opinion. The others are also very relevant, and most of this information still carries over to those as well. It just might look differently than what I'm going to show you today, but the concepts are the same. Coolness? So let's take a look. Components. EV3 came in two different versions. There's a retail version you get off the shelf at the store, or you get the educational version through legoeducation.com. They come with exactly the same hub, identical hub. They come with about the same sensors and things, some slight differences, but mostly, and they come with a bunch of Lego pieces. They're slightly different, but mostly the same. The biggest difference between the two is the education version comes with a rechargeable battery pack and a wall wart that plugs into the wall. For convention goers, if you want to plug this thing in and have it running all day long, that's beautiful. If you get the retail version, 6 AA batteries, you get to change out about every 2 hours, depending on how long your motors and stuff run. The other one does take the AA batteries as well, but the rechargeable battery pack just replaces it, which is a really good feature, really nice. Both very good. Has 8 ports on the hub, 4 for motors to control things, and 4 for sensors to get feedback and information. Kind of handy there, okay? The Powered Up system, which kind of replaced the Power Functions line. I see on LEGO Masters, they keep calling this like Power Functions 2.0, but then call it that, or pick a name, whatever. It's a pet peeve. But Powered Up system, there's lots of different hubs. They come in lots of different configurations. You can buy them just individually, or they come in some LEGO sets. Some cars, some vehicles, like the Lighthouse, I think might have had one. Different ones have different things. Lots of different motors, lots of different sensors, lots of different configurations of options that fit into these things and they plug in there. The hubs mostly have 2 ports on them. There's one that has 4 hubs. There's a new one out, I think, that has 3 built-in motors. That's really weird, but it's not programmable or configurable. That's really weird. But so fewer hub options. Okay? So you have less options to work with there. And of course, you've got the Spike Prime, which is the newest robotic system that LEGO has out there. This one only comes in one version. There's not a retail and an education version. It's the same version. You can get it off lego.com or education.com. It's the same thing. Kind of one you get points for and eligible for gift with purchases. Education, not so much. So. There's also an expansion set for this that I'll just mention real quick that adds 1 extra motor, 1 extra color sensor, and a bunch of extra pieces. Handy if you're doing a lot of stuff, but not required if you don't need it. This set is about $400. If you want to buy just the hub by itself, I think it's like $250. So just buy the whole set. You get all the cool stuff. It's way better that way. This does have a little version called Spike Essentials, which is a whole separate kit, whole separate thing. Has a little tiny hub. It's so cute. It's like 5 by 7, but only has 2 ports on it. And it does not have any stored memory, meaning you have to be plugged in or connected to it to run the program. As soon as you unplug, it's dumb. It doesn't know what to do. It stops moving. So I'm not talking about Spike Essentials today. But programming is kind of on parallel with it. Okay? So those are the systems that we're going to talk about. Is that cool for everybody so far? Anybody learn anything yet? Somebody. Okay, good. All right, devices and connections. Let's take a look at these. So we've got the EV3, the Spike Prime, and the Powered Up. They all have Bluetooth capabilities for connecting to your device for programming, which we'll talk about in a minute. Only 2 of them have USB cables. If you're old school and you're like, I like the cable. I like the cable. You can plug in the EV3s. You can plug in the Spike Prime. Powered Up does not have a data cable, a way to connect to it. Okay? So if you're connecting to a computer, a tablet, or a phone, obviously, wait. There we go. Is that better? Okay, thank you. So if you got a phone, obviously they all have Bluetooth, unless you got the Windows 95. I don't know that. Did Bluetooth even exist back then? I don't think it did. But if you got a computer, a tablet, or a phone, they pretty much all have Bluetooth. Some tablets don't work well. I got a student now with Chromebook, and the Chromebook is like really making things difficult at school, but you know, your iPad and your Androids, most of the primary tablets work better there. Sorry, Chromebook people. But if you want to do EV3, yes, you can work with a computer, you can work with a tablet. Totally, works great. Not a phone. There's nothing on the phone for that one. Okay? Spike Prime works with any of the platforms. You're good to go there. Whatever I got, I can use it. Can't use your toaster oven, don't do that. Okay? And if you got Powered Up, nothing on the computer is going to work with that one, but you can do a tablet or a phone. So different systems you're going to connect to different ways, and it's all confusing and it makes no sense, but there it is. It's really pretty. And I got nice lines to make it obvious, I hope. So, but just understanding that whatever system you're working with drives how you're going to control it. Sound good? Perfect. Love you guys. You're awesome. All right, software. Let's take a look at was that a question? Robot Inventor is the latest version of the Mindstorms line, and it's almost identical to, how many slides can go back? It's almost identical to Spike Prime, but it's in a different color. And the firmware that goes on it, and there's a chip inside that limit the firmware updates on that particular hub, and you cannot program Spike Prime app onto that hub. It's complicated. So you're limited to the Inventor app, which is now discontinued, and they don't support it anymore. So it's old school. It's still out there. You can get it. But it's like, we're not doing that anymore. Okay? So Spike Prime is more the same thing. There are some weird, ugly workarounds with some third-party systems where you can emulate Spike Prime stuff on that, but just if it's teal, stay away from it. That's my version. Oops, sorry, don't touch the mic. Don't touch the mic. He warned me. All right, where am I here? Software. Let's see what software looks like. So, EV3 software. This is an educational teacher version, and they have since updated it. It's a little bit different, but this is the version that I typically go with, and this is what the screen would look like if you're programming. Okay? Beautiful big area. You got this giant space up here is where you're building your programming code. And I'm going to walk you through this in a little bit. You build them horizontally by connecting these little building blocks of information, little code blocks. And you go horizontal. You get to pick your blocks from down here out of the block library. Whole bunch of blocks to pick from, and they're organized by tabs. Pick a tab, it changes what blocks are available for you. Hopefully you're familiar with those types of things. You connect to the hub over here and download your program. So whatever you program there, you click this button and it puts it on the hub through Bluetooth or through the USB cable, if you're on the right device. Okay? Once you are connected to the device, to the hub, you can get information from the hub. How's the motor looking? What speed is it going? What color does the sensor see? You can get real-time feedback from that, which is really nice. So for EV3, that's what the thing sort of looks like. I'll walk through this in more detail in a little bit. For Powered Up, again, you're on your phone or on a tablet. Same kind of thing. You got building blocks. You're going horizontal. You got a library. This one, you got to like scroll to get to your different apps. Drove me nuts. I had to get my reading glasses. I had to get a little stylus so I could not get my finger was too big and fat. Drove me nuts on a phone. Tablet would probably be a lot better. Okay? But again, you got a library here, or tabs, to get to your different libraries. Each one just changes what's in the library. Most of them are color-coded. This one you get to download. You don't download. You run the program from the app. This one does not actually take the program and download it onto the hub and then is stored on the hub. It's just running it. And as soon as you lose that connection or disconnect or close the app on your device, the hub goes dark. It's like, I don't know what to do. I don't know what to do. And then you reopen the app and you rerun the program. It's like, oh yeah, I know what to do, and it starts doing it again. But if your device, your tablet is turned off or the app is not active, you lose control. This made it really fun for me when I had my example that I built and I programmed it on my phone and I ran the program, and then I wanted to take a video of my machine running, so then I switched to the camera mode and it stopped because the app was no longer the primary app. So I had to get another phone. So if you have two phones, you're golden. You're golden, okay? There's a different button for connecting to the hub with the USB. Obviously, no cable on this one. And there's a little menu button over here, which is really handy, that slides out this little tray of options. This one slides up a tray of options. And this changes the complexity of the blocks in the library from easy, intermediate, to advanced. So if you click on the easy, you get like 3 blocks. It's like, go forward, go left. You're like, let's go intermediate. Okay, I can go backwards and I can go sideways. And if you click the advanced, it's like, dude, what do you want to do? Let's turn this thing around. And you get all crazy and you get all these program blocks. You're like, oh, I don't know what that does. Let's make it try it. So lots of different options there. So if you're just starting out, stick with the easy blocks, get comfortable with those, grow to the medium ones, go to the more, and grow up. Okay? We'll talk about that a little more. Okay? So that's the software there for Powered Up. Spike Prime, they changed things. We're now building in this area, but we're now building stacks that are vertical instead of horizontal. The newest version of the EV3 software, before they discontinued it, converted to this system. So we're going vertical stacks, which is kind of different, but it works. And if you've ever worked with Scratch, which is a programming system, it emulates that type of a thing, kind of becoming more standard. Your library is on the side here. You can, again, scroll that list up and down, or there's quick tabs on the side that take you to that section of the long scroll list, which is kind of cool. So just where the information is on the app. Downloading is over here. This one's kind of cool. You can change that 0. The 0 is a placeholder value on the hub of program 0. And you can say, I want to change that to be program 4. And you change it to 4, and now you've got one program stored in 0 and one program stored in 4, and you can run program 0 or you can run program 4. So you can store multiple programs on the hub and run them accordingly. EV3 does the same thing, except the programs have actual names and not just a number. Up here is where you connect to the hub. You just like click that, and then it opens up a little smart window that says, you need to now press the button on your hub. And you do that, and then it opens up the Bluetooth and connects it. The one weird thing that, I don't know, again, pet peeve for me, in Spike Prime, they have a button down here in the corner. Did I get to it? Press that button, opens up a beautiful big window with like 6 big blocks of information. It says, more programming blocks for movement, more programming blocks for controls, and there's like 6 of them, but they're huge for some reason. You click the checkbox, and then you come back here, and you get more programming blocks, like for movement, for the blue ones. Except it puts the more movement blocks at the very bottom of the list. They're still blue, but they're the more blue blocks. So I've got some of my movement blocks that are at the top of the list, and some of my movement blocks are now at the bottom of the list. It's a weird way to do it. I hope they fix that someday. But there are like more advanced, sort of like in the Powered Up app, kind of more advanced options there. Kind of cool? So that's what the systems look like if you like open up the apps and take a look at it. So let's talk about sequencing and what that means. If you're doing any sort of coding or programming, how does that work? So sequencing and coding, the process of coding is similar to baking. Everybody done baking? What'd you bake me? Brownies. Chocolate brownies. No? Darn it. Okay. So both systems there, you can use a lot of ingredients. Okay? Lots of different ingredients for baking, lots of ingredients for coding. That's just great. And you can mix them together any way you want. It's your choice. You get to figure that out. Go for that. Okay? But if they're not mixed well together, outcome's not so good. But you put them together in a nice, organized sequence that follows a good pattern, like Grandma taught us how to bake cookies. You do get the desired results. And that's what you look for. How you do that takes practice, takes time, takes troubleshooting and figuring out, both in baking and in coding. So hopefully we'll get through that. So let's figure out what that looks like. We use these code blocks, And if you want to do coding in this crazy cryptic letter, number, symbol, characteristic thing, you can do that. But the code block is basically doing that in behind the scenes for you. It does coding, and it brings it to you in a nice picturesque format with limited words. Words are hard for some of us, and that's okay. Okay? So when it does the sequencing, when you run the program, it does each command one at a time. It's not like, here's the program, let's do all of this stuff. No, it's just looking at one thing at a time. What does this command do? It'll do that thing, and then it's going to move to the next, and the next, and the next, one step at a time. So if you have a problem or it's not doing what you want, break it down into small steps, figure out where in that sequence is there a problem, or what do you want it to do next in that sequence. Just follow the sequence one at a time. That's all you get. There's some other ways to do more than one at a time, but I won't get into that. Okay? So, good on sequencing? Y'all know how to bake cookies for me now, right? Brownies, even better. Okay. Code blocks. We'll do a quick little dive into code blocks. I'm going to talk about 4 different types of code blocks in each of the systems. Motor controls. Typically, if you're doing some sort of system, you want something to move. If you don't want it to move, I don't know why you're doing this system, because it's probably not really doing much for you. So motor control is really important. All 3 of these in EV3, in Powered Up, and in Spike Prime will make a motor turn. Just turn it on and make it turn. And for the whole rest of the program, that motor will continue to turn. It will turn until the end of time, or until the batteries run out, or until you tell it to do something different. Okay? In EV3 and in Powered Up, you also get to control the speed or the power of that motor. These are both set to 50%. Spike Prime, it's a little bit different. You have to put in another code block to tell it what speed you want it to go to before you tell the motor to move. If you tell the motor to move, but you haven't told it what speed to go, it defaults to 75%, and it will just run at 75%. But if you want like 40%, you got to say, set motor speed to 40%, then start motor. Kind of weird, but it works that way. You can also tell the motor to move. These are servo motors, so they're not just a motor that when you put electricity to it, it spins. It's a servo motor, so it actually has sensors in there, so it knows how fast it's turning, how far it's turning, and you can tell it to say, hey, I want you to turn 90 degrees. And it'll move 90 degrees and know how to stop at 90 degrees. Or I want you to go 2 full rotations and stop. You have the options to control how much that motor is turning. Very different than the days of just power functions where you like plug it into a battery, turn it on, motor goes, and it's really cool, right? Just like that. That's what it does. Yeah. So here we get to control how much. In the EV3, it's the same programming block. You just click a little drop down and you change some settings and you say, I want to move motors by degrees or by rotations, and it'll give you different options there. In the other 2, you have to have a different program block. But again, you're just telling it the same systems. So if you know, hey, I want this motor to turn around twice, just go find that block that says move the motor 2 times in a circle. And find the right block and it'll do it. If you plug in the wrong block, it's going to do something different. Go find the right block. Okay? And then if you want the motor to stop, you can tell the motor to stop. So this is most of the motor controls. There's a few others that do some other more weird things, but basically, how to turn the motor on, how to make it move a certain amount, how to make it stop. Kind of cool. So wait blocks are a way to pause that sequence. So instead of going, oh, quickly, make the motor go on, okay, now do this, now do this, now do this, maybe like, whoa. I want to wait a minute before I go do the next thing. You can put in a wait block. This will wait for 1 second. You can wait for time. If you want more than seconds, you just retype something different in there and you can change the seconds. Okay? In EV3, you get a drop down and you can change what you're waiting for. You can wait for a sensor to give you a different value. You can wait for inputs. You can wait for data logic. You get all those drop down options of things you can be waiting for. Powered Up and Spike Prime, you get a different program block for waiting where you have to put in the information of what you want to wait for. It's just a different thing. Tell me what you want to wait for, and it'll do it. I'll show you all this in real sequence. Okay? If then else's are ways to change the data flow. How are we moving from one sequence to the next sequence? What do we want to do? These ones give us like an A-B option or a left-right option. where you get to choose. Well, if this condition is true, do this sequence. But if it's not, then do this sequence over here. You get to choose your path. Sort of like a choose your own adventure book, right? Billy climbs the tree. He sees a squirrel. What does he do? Poke the squirrel with a stick? Go running home. Tell mom. Which one are you going to do? Choose your path. Choose your path. And the paths can be driven by sensor input, logic, numbers, values, lots of different information that you can choose to decide which way you're going to go. In Spike Prime, you get an if-then statement, which says, if this condition is true, do that sequence. Whatever's inside that little clamshell picture there, do whatever's inside that bracket. If not, well, skip it. Just move on. Or you get an if-then-else statement. If the condition is true, do the first clamshell. Otherwise, do the second clamshell. You're going to get an A or a B, versus the first one is just get an A or don't do the A, which is kind of like a B, but the B is like do nothing. Too confusing? Did I just blow some minds there? You still don't know. Okay, cool. So loops are when you did something, you're like, oh man, that was awesome, let's do it again. And there you go. You just go and you loop and you do it again and then you do it again. Whatever commands, whatever sequence you put in there, it could be a long sequence, it could be a short sequence. Turn the motor one time in a circle. Cool, do it again. Turn the motor in a circle. Cool, do it again. If you put it in a forever loop, forever. It just goes, it goes. Or you can have conditional loops that allow it to go a certain number of times or based upon a condition of another input, like a sensor or some other information that you have there. Okay? So different types of loops. So those are just 4 different types of blocks of each of the different systems. They all do exactly the same thing. They just look different. A different picture, it's a different color, different shape, does the same thing. And this is true if you're doing Python coding or any other type of coding. Does the same thing, you're just coding it differently. So here's 3 different ways to do the coding. Sound okay? All right, good. So just to let you know, in EV3, these are the code blocks in each of the different tabs. So the top one is the green tab, the actions, the flow, the sensors, the data, the advanced. Don't worry about the advanced ones. They're scary. I don't use those. They scare me. But the other ones are really cool. Okay? Spike Prime, these are the blocks. They break them out a lot more simplistically. In EV3, they might give you one block that's like, increase, decrease, or modify this value. One block. In Spike Prime, it's like, well, here's a block for increase. Well, here's a block for decrease. Well, here's a block for this. It's like, oh, can't I just get one block? No, you got to get individual blocks. They all do different things. Yeah, lots of blocks. All right. How do you say that? Why is the P in there? I don't know. Pseudocode. Pseudocode. Pseudocode is something that coders and programmers use, lots of people use. It's a way to describe the steps of your program using plain English. Just write it out without having to worry about the coding. Before you even get to the coding, know what you want it to do. So write it down. So we're going to say, that's me, except he has hair. Okay? I want a dragon that moves in and out of a cave. You guys see my dragon down there moving in and out of the cave? Yeah, I built that for this talk so I could have something to talk about. Okay? And then I made my little clip art, which is the cue. So that's what I want. Me thinking, I want a dragon that moves in and out of the cave. Okay? I know. I'll mount it on a little platform, and I'm going to use a reciprocating motion. If you took my other talks, you know what that is. That's good. And we're going to have it, we're going to use a color sensor. I'm going to look and see a color, and on my little skid that's going to slide back and forth, I'm going to put a green brick on one side and a red brick on the other side. And when I see the green brick, I'm going to tell the motor to move one direction. And then when I see a red brick, I'm going to tell it to move the other direction. And then I'm going to put that in a loop. I'll do it again because it's pretty cool. Okay? And we'll just go back and forth. Green, red, green, red, green, red. Okay, that's what I want. That's in my mind what I want to happen. I plan that out. So I'll write that down on my pseudocode. The color sensor sees green, move the motor forward. Otherwise, that's like an if-then-else statement or one of those switches. If it sees red, move it backwards. and then repeat. That seemed like a pretty easy code. Is it scary? It's a little scary for some people. Okay, not for most people. So let's take a look at what that looks like in each of those three systems. Okay? Walkthrough. What are we doing here? This one's a little slow. This one was hard because, again, I couldn't do my video camera well on the camera. I had to take a camera of a camera. Didn't work so well. So in Powered Up, we're going to put some coding right here. I'm going to grab this block and drag it up. It's a forever loop. So whatever I put inside there is just going to keep doing it forever. We're going to put a sequence of stuff inside this forever loop block. And the block will stretch out the more I put in it, which is kind of handy. Okay? So I want to put in that a switch, which has an A or B option. So now I have two paths. And in the logic check, well, when we run the program, we can say, click, run program, enter the loop, make a decision, A or B, based on the condition that the program sees, and either do the top path or the bottom path. And then when I get to the end, what do? Do it again. Thank you. Excellent. Fantastic. Do it again. And we're going to go through that. So let's go and switch over to the tab that has the math blocks on it. Pick one that has math of an equals value, because I want to find something that equals the value of a color sensor. What did I want to know? Is the color sensor, I forget, green or red? One of the colors. So we pick the color sensor, drag that, and it connects. You see like little puzzle pieces that click in there? Kind of cool, little clicky pieces. So if the color sensor, which is on port A, equals, and here I get a little drop down that says, well, what color do you want it to be? The computer doesn't know colors. It knows numbers, but it equates all the numbers to a color. And then we get our lovely little interface that says, well, if it's green, the computer thinks that's number 5. I don't know why, but somebody made that number 5. So now I have a system where if the color sensor equals number 5, the color sensor is looking at a green brick, I'm going to do the top path. We'll take a motor block and put a motor block up here. Now my top path is make that motor move. Make sense? Hopefully. Too simple for you guys, right? Some of you. Okay, most of you. I know. But I do have to change the port for the motor. If I have the port on motor A and the color sensor on port A, they're both port A. They both can't plug into the same port, so one has to be port B. And on most powered up hubs, you only get 2 ports, A and B. Okay? So now I've got that. There's my first condition of my pseudocode. If the color sensor sees green, move the motor forward. Good. That's the first part. I like it. Then I'm going to use this little drop down that gives me a copy paste option. And I'm going to copy that whole statement that I just made up there. And I'm going to copy and paste it, this little shortcut, and paste it in the other path. Does that make sense? Good. I'm getting a couple nods. I'm getting a couple people yawning. So it's either one or the other. Then what do I need to change? I just need to change the color, change the other one to red. And for the motor, I need to change the direction because I want it to go the opposite direction. On this particular one, positive numbers are forward, negative numbers are backwards, or move the motor the other direction. So I just changed the value to a negative of the motor. Does that make sense? Forward, backwards, okay. And there we go. Now I've got my second condition. Very simple change. If it sees red, move the other direction. There we go. There's my code. And it's all in a loop. So run the program, enter the loop, make a decision. Is it red or is it not red? Or was that one green? Sorry, was it green or not green? I forget. Green, it's going up here. Hit the loop, do it again. Go back. And now the motor's moving the other direction. Okay, so the thing's moving along. La, 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 la. Eventually, I'll just keep looping through here. If it's not green, it's not red, it's black. I'll come down here. Go there. Now, if it's black again, I'm just going to hit that bottom path. I don't do anything. It's just going to hit the loop. And it's just going to keep looping through until I get to a red or a green. When I do find the red, send the motor the other direction and keep looping back. It just, the loop is going through, doing each of those things in sequence, one after another, again and again and again. And it will look, if it works, like this. It's green, it's red, it's green, it's red, it's green, it's red, back and forth. That's my program. You see the color in there? Seem pretty simple? Does it seem really confusing? Does it seem overwhelming? Some people are like, Brandon, can you go back to the first slide? We need to start over. Okay, so let's take a look here. What if we did the same thing This goes a little bit faster the second time. In EV3, same kind of system. Got a start block. Got to go into my second tab. Got to find a loop. Drag the loop up in there. I wish I could make this go faster. I feel like it should go faster. Pick a switch, which gives me the A-B option. It doesn't go on the outside. It's got to go inside the loop. It auto stretches and fits it in there. I'm a little fastidious, so I got to line it up where I can see the whole thing. And I get to tell it what kind of a condition of a switch do I want. I want it based on a color sensor. I could pick any of these options, but I want the color sensor based on color, and I want it to be the color green. So we'll do checkbox on green, but not red. What's that? Green screen, yeah. Is it 3? Did they change the numbers? They totally did. Okay, so in this one it's 3. Yeah, LEGO. What were you thinking? It was a new team that year. They picked a different value. So again, I'm just setting the motor, and I can tell the motor to, again, turn for a certain number of rotations, a certain number of degrees, but I just want it to turn it on and start moving the drag in the other direction. So I just say turn the motor on. After that, it's going to stay on for the whole rest. As long as the program's running, the motor is going to stay on, go in that direction until the batteries die or until I tell it to do something else. So once I have that, there's my first condition. If I see green, go this direction. Again, copy paste. Nice way to save some time on the programming. Or I could have dragged the little blocks up and dragged the little block up and recreated it, but I had it already mostly there. Change the color to red. And what else do I need to do after changing the color to red? Change the direction. Well done. Easy. Change the direction. Again, negative value goes the other direction. There we go. That one's all set up. Let's take a look and see what it looks like. Same build, just a different motor and a different hub and a different color sensor. You notice it's a different speed too. The powered up motor didn't have as much torque. So when I tried to run it at a slower speed, didn't have enough energy to get the dragon to move. So I had to ramp up the speed until it could actually get it to move. This motor has a lot of torque. He's your friend. So you can run it at a lower speed and still make that thing move, which is kind of cool. All right, let's take a look at this whole thing in Spike Prime. What does it look like? This is the opening thing you get in the Spike app. You get both the Spike Essentials and the Spike Prime, both programs in there. Remember the Spike Essential, the little junior version with 2 hubs or 2 ports? It's cute, but not super practical for a lot of things. So you get to give your program name. You can program in Python if you want to, or you can program in like picture blocks if you want to do it's very pictorial. Move the motor that way. Move the motor that way. But we're going to go with this one with the stack blocks. So start the program. When the program starts, what are we going to do? We need a forever loop. Scroll down until we find the forever loops. Plug that in there, and then as we build within that, it will stretch out accordingly. We just have to make sure we place things in the right place, otherwise the sequencing will be off. We want sequencing to be proper. Okay. So here with this funny little shape block, we get to plug in a condition. We have a whole lot of different conditions, mathematical conditions and sensor conditions. This one happens to be for a color sensor. If the color sensor in port A, port B, apparently, is green, and I don't know what value it sees. It doesn't tell me the number here. Probably something different though, right? Yeah, thanks, Mike. Turn the motor port A, make it go this way. It just has an arrow. It just is kind of cute. And there we go, there's my first condition. The second condition needs to check, again, the color. So we've got to go back to my sensor, find the color, plug that one in there, make sure the port changes. The most common mistake in all of this programming is your thing's programmed for the wrong port. Everybody does it. Don't feel bad. You'll do it too. If you don't, you're lying to yourself. You'll do it. You'll do it to yourself. Everybody does that. Okay? So there we go. That's a pretty good condition there. Seem pretty straightforward? Okay? The only thing I noticed here is I didn't set my power at the beginning. So if I don't want it at 75% power, I have to set it at the beginning. In Spike, once you set the power condition, it's like setting a speed limit sign on the highway. That's the speed limit till the next time you see a speed limit. You're going to be going that speed. So I set it to 40. We'll go 40% power. Every time I tell the motor to go, it'll go 40%. Now it looks like this. Different hub, running program 1, in and back out, in and back out. I had fun building this so it would adapt to all 3 motors and all 3 sensors. I'm like, okay, how do I do this thing? All right, so whatever system you want to work with, they all do the same thing. Little subtle variations of differences, but they all do the same type of thing. Okay? Does that feel a little comfortable? Okay, good. Problem, if the eyeballs or the sensor is in the middle between the 2 blicks, when you say run program, well, what's the program doing? If I see red, go forward. If I see green, go backward. If not, don't do anything. Well, did I see red? No. Did I see green? No. Okay, don't do anything. So it will never move. So, and also I noticed the dragons just like in and out, in and out, in and out, in and out. I was like, oh, the dragons don't really work like that, do they? They hang out in their cave a little bit longer. So what if it hung out inside the cave a little bit longer and outside the cave a little longer? So I just went in and said, well, okay, so when I start the program, do I care what direction it goes at the beginning? It's in the middle. It's either got to go to red or it's got to go to green. So I don't really care. Let's just put in a move motor. It can go forward or backward. It's going to pick up one of those sensors eventually. It doesn't really matter for this particular model. Different models, different conditions. But don't build this. I already built it. Don't copy me. Okay? And then for each of the motors, when it gets to green, instead of immediately going the other direction, stop there. Wait inside the cave a little bit. Chill out, dragon. You're having a good time in there. Wait inside the cave for 3 seconds, and then go the other direction. Then when you get outside the cave, stop. Stop the motor. Then wait for a few seconds. Maybe longer. I forget which one's inside, which one's outside. I don't remember. But 5 seconds or something like that. Okay, that's pretty cool. But this one also has a problem. As soon as it gets onto the red, it says, okay, stop and pause, wait here for 5 seconds, and then commence again. Okay, so it goes through the loop and says, well, if you're on red, yeah, I'm still on red. Okay, stop and wait and pause for 5 seconds. Okay, I did that. Okay, now what? Okay, now we go through the loop. Check, are you on red? Yeah, I'm on red. Okay, stop and wait and pause for 5 seconds. Even though it does say move the motor, but immediately it says move the motor, check in red. I'm on red. Okay, move the motor. Yeah, I'm on red. And it never like gets off the red. So I put in a wait for half a second. Start moving the motor, wait for half a second, and then it's like, okay, now I can check. So I've cleared my condition, so I'm not looped into that. I'm just on red. I'm so happy. And you never get off of it. So it took a little bit more programming to make all that happen. And then we get something like this. Program 3. Move out. Wait a little bit, go in, wait a little bit, go out, wait a little bit, go in, wait a little bit. Okay, so when I started with my original pseudocode, it's evolved a little bit. But my pseudocode starting gave me a good time. Okay, great, perfect. Okay. So what I ended up doing, I like to program in EV3, so this is my EV3 program that I ended up with until 3 days ago when I decided to add some other stuff to it and change it. It looks more complicated because each block has a lot of conditions within it, and I did program like a pause button where I could choose to pause the program. Since then, I got rid of that, and I added in my little motion sensor, which could detect people as they walk by. So, but it's a kind of cool program. And now we come out. He snaps his jaws a random number of times, 1, 2, or 3 times. He goes inside. He waits inside for a random amount of time, between like 2 and 5 seconds. And then when he comes out after he snaps his jaws, he stays out there for a random amount of time, between like 3 and 7 seconds or something like that. So it's got a lot more randomness to it, which makes it kind of fun. Harder to do random type motions like that through mechanical movements. It can be done, but it's a little crazy. Talk to Jeff Strong out there, who's done the ferry boat that moves back and forth. That thing is awesome. Okay, it's got mechanical movement, it's got physical movement, it's got beautiful diorama, beautiful stuff. Yeah? All right, I'm running out of time, but let's take a quick look at apps and programs. So if you want the EV3, you can get the EV3 home version, or there is a classroom version. They work on both hubs. The classroom version, I just noticed they're discontinuing it next year. So if you want that version, download it soon before it's gone. But you can get it on Mac OS or on Windows 10. I'm assuming it'll be good for Windows 11, but who knows? It gets kind of weird nowadays in like October, right? That thing gets weird. Spike, you can get it on a lot of different platforms. Chromebook, not so much is what I'm learning. There is a Spike web version where you can actually control it through a web app. I don't know if it's a web app or is it just the web version. I don't know, you got to go to like spikeprime.com, something, and there's a way to control your thing through that. And that will work on the Chromebook, but it's not actually downloading the app. I'm just figuring that out at school this last week, so that's new for me. And then Powered Up runs on a bunch of different things. So depending on what you have, what you want to work with, the program can be in a lot of different places. Just got to kind of go to it. If you go to the LEGO site, it leads you to all those information, and you can track that there, which is kind of helpful. All of the different systems have wonderful help files that break down and describe what things do, mostly. Some of them will say motor block, motor movement block. Description, moves the motor. Thanks, LEGO. Most of them give you a little bit more information than that, which is pretty good. So with that, that's my quick talk. That's quick introduction. That's like as basic as I could get it, because I don't know who's coming to this thing. If there's a Microsoft program in here, sorry, I wasted your time. Or any program for that. But I do have a few minutes for questions. So questions are through the mics, or if we have any online questions, I'm happy to do my best to answer that. Or if we run out of time, I'll hang out outside afterwards to answer any more questions. Yeah.
Okay, if we are one of the unfortunates with the teal-colored version, so will the
poor unfortunate soul?
Can we get the EV3 hub to at least work with the motors or something? Can we use portions of that?
If you have the Mindstorms Inventor app, the teal version of the Spike Prime, it works. You can get the app and run the app, and it will work perfectly, and it'll do all the same type of thing. But it's the updates version. It's cut off. They're not updating it anymore. They're not supporting it anymore. You get the app as it was. And that's fine. If you wanted to force it to become a Spike Prime by changing the firmware inside it, you can do that to a Spike Prime 2.0 version, which is the Spike Prime Legacy version, which works fine. There's a weird way to do that. I've never done it, but I'm on enough forums of people that do it, and they ask all the time. There's information online to how to do that, and I can talk with you more directly to help you guide that way. But then again, it's locked into an old version of Spike Prime. So it's either going to be Robot Inventor app or an old Spike Prime app. And I think if you want to do it as a newer version, you have to use a third-party system to get that to work. We got.
For somebody who is newer.
It really depends on what you want to do. If you really just want to tinker and play, and depending on your budget, the powered up stuff is kind of cute, and you can just kind of do it on your phone and tinker and play with it a little bit. I find it harder because it's so small, but maybe on a tablet, that's better. As far as functionality and how robust it is, I think the EV3 is great, but again, it's a little older and outdated. The Spike Prime is great. I don't know if I mentioned that, but the Spike Prime has 6 hubs, and they can be for either motors or input. So you could have 6 motors on this thing, which is kind of cool. EV3, you're limited to 4. Although you can Bluetooth connect multiple of these hubs together and they can talk amongst themselves, you can't do that with this one yet. So it's hard to say exactly. If you want newest, greatest, most recent, Spike Prime's your baby. I'd go with that. $400, but it's a nice system.
Thank you very much.
You're welcome. You're welcome.
I have 2 questions, but they're quick. So I think that when I was shopping for this, I noticed the Powered Up and the Spike. Those 2 systems have the same cables, the same port connector.
Yes.
And does the EV3 have a different one or the same?
Yes, great question. The EV3 and the EV3 components, like the motor and sensors, do not have wires on them. They have their own cable, which is like an old RJ11 phone cable, if you remember those. when phones plugged into the wall. Remember that? It's similar to that, but not exactly. So they have their own cables. It's a weird proprietary thing, and they come in 3 different lengths. You get your own cables. They break, you get a new cable. All of the new systems, the wires are attached to the devices. So if the cable gets damaged, get a whole new thing. Kind of bummer. And the cabling on the end, whether it's powered up or spike prime, are exactly the same, and the components are interchangeable. So if you have a powered up color sensor, you can use it with spike and vice versa. This is a spike prime color sensor, powered up hub. That's actually what I use in my video because I don't have a spike prime color sensor or a powered up sensor, and it plugs in and will work just great.
Do you want the second question, or should I take a turn?
Go for it. Go for it.
Okay, the second question, you mentioned that EV, you get to save the programs by name. In Spike Prime, you get to save them by slots or like on the hub.
Yep.
In Powered Up, can you save your program on one tablet and put it into another tablet?
Ooh, I don't know. I've never done that.
How to.
I don't know.
Okay.
I don't do tablets. They scare me. They're weird. But assuming all the devices that I know of are saving the program somewhere. So assuming you could access that file and have a way to move it to another device, it should work in the other device too. I would surmise, but I don't know for sure. Yeah, that's why I like everything that like runs on a computer, because I can go dig into it, and I can find that file, and I can throw it on the thumb drive, and I can move it over here, and I can open it on that one. Go over here.
We have a question from virtual. Bets from online would like to know what program is the most user-friendly?
That's tough. Everybody's different. Everybody sees things in different ways, and their minds think in different ways. I had a hard time learning how to use the Powered Up app because the icons didn't make sense to me, and they didn't work with my years of programming that I've done. I'm like, I don't even know how to do that. I just want a color sensor. When it sees this color, turn it on. It took me like 2 weeks to figure that out, and it was painful. So I guess I'd say probably Spike Prime is probably the most user-friendly because it's really broken down and you're just reading the blocks real clean, real straightforward. Let's go one more and then we'll wrap things up.
So maybe it's more of a physics kind of question.
Oh, goody.
Depending on the orientation of the motor in your mock,
Yes.
does backward and forward change?
Yeah. I don't know them. I can never remember, but
Okay.
if you say turn this motor forward, it's going to spin either clockwise or counterclockwise. Okay. I don't remember.
Okay.
And some of them have connections on both front and back. So I don't know if it's clockwise, but I went on this side, so it's not. So hook it up, tell it to move forward. If it's the wrong direction, go the other way.
Thank you.
That's like, is that too simple? And if you figured it out, kudos. All right, I gotta wrap up. Go real quick.
Just really quick on the inventor teal
Yes.
brain. I know you keep talking about we could switch it to Prime. How complex of a device are we talking we would need to make that switch versus just use the inventor as it is with the inventor app?
You can do that. You can use it with the inventor app to make the switch. You just do it with your computer. You just got to download.
I mean, if we don't want to make the switch,
don't make the switch. You don't have
right?
to.
I mean, how much can we still do without making?
Everything that was originally designed for, and 99.9% of everything that I just showed can all be done with the inventor app.
Okay, so I'm trying to figure why would somebody want to make the switch?
Because the new stuff's cooler. No, no.
Okay.
Yeah, I've not worked with it, but everything I'm hearing is like, oh, why did I get this? So, and it's so unfortunate because Lego released that thing, and then there's like within a year they're like, we're canceling it. Like, frustrating. All right.
Two quick things.
Oh.
I walked in a little late. I heard something about cookies and brownies.
Cookies and brownies. Brandon loves cookies and brownies.
Real question. With Prime, when you use whatever device you're using to program, do you have to keep it connected to like the programming box?
Not when you're programming. You can do all your programming, and then you connect either with a cable or Bluetooth, and you download the program into it.
Okay, and then you just...
You download it, and then you run it from here.
Okay.
Both of these, you download the information, and it stores it on here in its brain, and then you run it from there. This one is brain dead. All the hub. Okay. Who learned something today? Was it worth your time? Yes? Kind of. Why did I waste an hour here? Okay, thank you. You guys are awesome. Thank you so much.